All right, we are going to be looking at sequences again today. We've looked at sequences before. It's not anything that you haven't seen. So what we're going to do is we're going to look at a few examples, remember how notation works, remember how to do an explicit and a recursive formula. So I'm going to start with a pretty simple one to start. I've got 7, 11, 15, 19. This is number 2 from your worksheet, and we're going to look at it in some detail. I'm not going to just do what number 2 is asking. The first 4 questions are just asking you to determine if this sequence is arithmetic. Remember, arithmetic is adding the same thing each time. Right? So if it's arithmetic, you're adding the same thing each time as you go. So this one, I've got plus 4, plus 4, plus 4. So it is arithmetic. And my common difference is going to be 4. I'm adding 4 each time, and that is our common difference. So now that I've gotten that, what I can actually do is I can use this information to write an explicit and a recursive formula. One thing, this worksheet uses a little bit different notation than CPM does. If we remember, CPM used this notation. So I've got for my explicit formula, explicit, I've got that T of n is equal to my common difference times n plus my 0th term. Okay, so when we're looking at this, I know that my common difference here is going to be a 4. And then this piece right here is my 0th term. It's like what would come before my 7. So that's going to be a plus 3. So T of n is equal to 4n plus 3. The notation that they use in the worksheet is actually the more common notation. CPM kind of used their own with this T of n. But the way that they do it is they say a sub n is equal to 4n plus 3. That's the only difference here, right? Is instead of using almost this function notation, they have a sub n. So if I know that if I want to know what a sub 1 is, I'm going to take it and I'm going to plug a 1 into it, and so I get that a sub 1 is going to be 7. Okay? That's how to get your explicit formula. You have your common difference times n plus whatever your 0th term would be, so working backwards. Remember, this is very similar to mx plus b. Very, very similar to that same idea of writing that equation if you've got your points. Here you're figuring out what your y-intercept is, right? Your 0th term. Your common difference is also your slope. Recursive work a little bit differently, right? For recursive, we had them look something like this, like my first term is a 7, and then in order to get to my next term, I take my previous term and then I add 4, right? So this right here is my common difference, and this is my first term. Okay? And then once again, using our actual notation that you're going to see on that worksheet, it's just a sub n plus 1 is equal to a sub n plus 4. Let's look at another example of a sequence and see if we can write these 2 equations. So let's say I've got -6, -3, 0, 3, 6, 9, and then so on. If I'm looking at this, each time I'm adding 3 to get to my next one, right? So my common difference is going to be 3. If I want to know what my 0th term is, I'm going to have to work backwards. So instead of adding 3, I'm going to subtract 3. So that's going to give me a -9. So if I want my explicit formula, that's a sub n is equal to, I've got a 3n minus 9. For my recursive, I've got a sub n plus 1 is equal to, I'm going to be able to figure out what, I need my a sub 1 is equal to -6. And then I just take my last term, and then I am going to add 3 to it. I just take my common difference and add it there. So my recursive equation, remember the recursive is just telling you how to get from one piece to the next. It's like your rules, right? If I tell you your first term's -6, each time you add 3 to get to the next one, okay? All right. Now, finding these sequences, if you're not given all of the information, let's say that you are given that a sub 1 is equal to 4 and that your common difference is equal to 3. Okay? In order to figure this out, I need to kind of start with my sequence, right? My first term is 4, and then my common difference is 3. My next one's going to be a 7, then an 11. Oh, no, sorry, a 10, right? I've got to add correctly. A 10, and then a 13, 16, and then so on, right? If I want to, I can use this information to write an equation, right? I know that a sub n is equal to my common difference, so 3n, plus whatever my 0th term would be. So I've got to work backwards, and I'm going to end up with a 1, 3n plus 1. This is going to be helpful because they want to know what is the 52nd term in my sequence. I do not want to work my way up there. That is not going to be fun. It's very tedious and opens myself up for many mistakes. So instead, I can just plug in a 52 into my explicit equation. So a sub 52 is equal to 156 plus 1. So 157 for my sequence here. Okay. Now, sometimes you're going to be given that first term, which is handy because then I can just work my way there. Other times you're not. Other times you might be given something like, this is number 11. They tell me that a sub 18 is equal to 84, and they tell me that my common difference is 4. This is where thinking about these in terms of just a linear equation is really, really helpful. If my common difference is 4, that means that my slope is 4. My 18th term is 84. That means that if I plug in an 18, I get an 84 that comes out. So if I'm looking at this, I can use this to write an equation. I can just use my y equals mx plus b, and then I can change it back into that function or sequence notation when I'm done. But I know that 84 is equal to 4 times 18 plus b. 4 times 18, I don't have a calculator handy, so 4 times 8 is 32, so 72. 84 equals 72 plus b. Right, so I can subtract 72 from both sides. And so I end up with my 0th term is going to be 12. So that means that if I've got a common difference of 4, my 0th term is 12, I've got a 4n plus 12. They want to know what a of 39 is, right? So I can just plug a 39 in here, plus 12, to figure that out. 39, 4, 36, 4 times 3 is 12, 13, 14, 15, so 156 plus 12. So my 39th term is 168, okay? You might also just be given 2 different points, so to speak. You might be given that a of 12 is equal to 20, and that a of 15 is equal to, we'll go with 26. Okay? So if I'm looking at this, sometimes with these ones I picked them close together. They might not be close together. You might have, in fact I think you have like a 16 and a 39 are the terms that you're given, so you can't just really kind of figure it out by listing out your points. Instead, it's going to be really helpful to once again think about these in terms of 2 points, and you are finding the equation of that line just like we did before. My common difference works just like my slope, right? So I've got my change in y, so 26 minus 20, over change in x, 15 minus 12, so 6 over 3. My common difference for this one is just a 2. Now I can take it, I know y equals mx plus b, and I can figure this piece out. I can plug in my points. So I've got that 20 is equal to 12 times 2 plus b. That's 24. I can subtract 24 from both sides, so I get that b is equal to negative 4. So plugging all my pieces in, a sub n is equal to 2n minus 4. And if I want to know what, say, maybe a of 41 is, I can just plug it in. Right? That's the beauty of our explicit formula, is it lets us just plug things in there. Okay? So remember, thinking about these in terms of just the equation of a line. That's the easiest way to think about it. We always do want to go back and get away from our x and come back to n, because remember, that's what makes sequences different, is I can only plug in 1, 2, 3, 4, 5, and so on, right? But if it was an x, I can plug in whatever numbers I want. If I just have an x, that implies that I have no restrictions on my domain. This tells me that I can only plug in those natural numbers. Okay? So hopefully that'll be enough to get you through this. Really take your time and remember, all that you're doing is you're just writing the equation of a line. It looks a little bit different, but it works the exact same way. All right, good luck. Remember, let me know if you need anything, and I miss you guys. Talk to you soon.